Yeah, so once I get my slides, we'll start. Please. All right. So, welcome back for those of you who were here earlier for the previous V6 tutorial. If you're new here, what I've been doing so far this morning is talk about the different V6 transition technologies. Okay, I'll rephrase that, talking about the various useful transition technologies rather than the 101 other ones that have been dreamt up over the years, many of which are now either obsolete or totally insecure or totally inappropriate. So if you weren't here when the slide set discovers really what the industry is realistically using, in other words, what we see out there in the internet industry. So based on and armed with the knowledge of what we did before the coffee break, we're now going to look at doing a bit of deployment planning. I'm not going to claim that this is the only way of doing things. This is the way I've been doing things. Probably different from how some other folks might have been doing things, but that's good. There's no one way to plan a V6 deployment on network infrastructure. So anyway, introduction. So I'm Philip Smith, work part-time for APNIC, and so doing these tutorials for the conference for you. The slides are available on, well, this is just my own FTP archive. They're also available on the APNIC 38 website. They went up there yesterday. So please feel free to grab them if you wish. Also, as the session was before the coffee break, please feel free to ask questions. Then I don't have to stand up here doing all the talking. If we can get some questions, I will repeat them, or I'll aggregate and repeat them because the session is webcast and being recorded. So it's just so that, well, there's not a long pause of silence and nobody knows what I'm actually answering when a question is asked. So I will repeat the question for the benefit of the webcast. All right, so what we're going to look at. This one is a high-level planning consideration which any network operator needs to be aware of prior to deploying IPv6. In the V6 workshops I do, I have a lower level one. So for each section in the lower level one, I start getting into router command prompts and all the rest. I will spare you all of that, and I'll spare you the command line interfaces and specific details. But just try and keep it at a slightly higher level so you can do a bit more strategic thinking rather than getting worried about Cisco or other command line interface. So I generally think this is applicable for business decision makers, network managers, network engineers. Implementation details, of course, well, network engineers will know how routers function and so forth, so we'll know how to follow on from what I suggest here. The agenda looks long. The 8 points here, they're not really so long, but I think these are the 8 steps. I should probably count them 1 to 8 rather than just doing blub, blub, blub. But these are the 8 steps that I have been following when I help other network operators deploying V6 on their infrastructure. If it looks like a funny order to you, well, there's a method or a reason for why I've been doing it this way, as we'll see as we step through the slide set. But notice IPv6 doesn't really appear onto the 4th bullet. And so there's actually quite a bit of work that needs to be done. You don't just wake up one morning and have your cup of coffee or tea and think, I'll deploy IPv6 today. Doesn't quite work like that. And so we need to actually sit down and think of a more structured approach to doing deployment. Notice customers come right down at the end. Right? You don't give V6 to your customers as your first act. Your customers are probably the last people who get V6 before a lot of other things in your own infrastructure. All right, so what do we want to achieve? Ultimately, we want to provide v6 to customers. So whether these customers are end users, like the common home user or business user or and so on, your customer could well be content provider as well. As we get into businesses and bigger enterprises and government organizations and so forth, they're content providers. They run their websites. They want people to access them. They want people to buy things, sell things, fill up forms, apply for stuff, find out statuses, and all this type of thing. Strategy you're going to use depends on your network transport. The two network transports commonly used, the native IP backbone, which has been the historical long-term internet infrastructure, and the MPLS backbone, which are basically tunnels over an IP infrastructure. So these are the two types of infrastructure that you have to consider for our service provider backbone. If it's a native backbone, well, it's dual stack. Right? Customer connections connect to the native backbone, VPN services provided by GRE, IPsec, IPNIP, etc. So if you're going to provide v6 to your customers, it means upgrading the native infrastructure to dual stack as well. So I've drawn this. I've drawn lots of little IPv4s in black, and I've drawn lots of little IPv6s in red, just to show how this is going to be. For the MPLS backbone, I hesitate to say that MPLS infrastructure operators have an easier life. They probably don't, but it looks easier as far as the picture goes. Because the core network for an MPLS infrastructure doesn't actually need to be v6 aware. You do not need to go into the core network and make it dual stack, because all the v4 doing is carrying all the, I suppose, the VPN info around. And you can use any protocol for that. It could be carrier bridging protocol for all the routers care. But IPv4 is there, and it's probably going to be there for many, many years. It's quite interesting speaking to the vendors, because they say hardly any network operator has asked for v6 to be available in the core of an MPLS infrastructure. Yes, they want it for the edge, so connecting to the customer infrastructure, but nothing for the core. So I could say deploying v6 for an MPLS infrastructure is very easy, because you just need to switch on 6PE or 6VPE or whatever you fancy, and it is all done. And it's certainly true. Some of the big global operators have turned on v6 support in, well, the quickest one was 3 days, and another one a former colleague of mine now works at did it in 7 days. That's a global network. We're talking like 1,000 routers plus, and they did it in a few days. So that was pretty impressive, certainly compared with trying to do a dual stack global infrastructure. So those are the two. Doesn't really make much difference for the rest of the presentation. You're still going to have to look at making something dual stack in the network. So what we're going to do, have a look at what you've got in your network. Now, unless you're a brand new network operator, you probably haven't documented very much. Or if you have documented it, the documents are probably 10 years old. I mean, I used to work for an ISP. I helped lots and lots of ISPs over the years. We all know, network engineers, the last thing we do is document things, because the documentation is up here. So, manager says, oh, you need to write this up. Yeah, I'll do it, but I need to fix this first. Which becomes fixing something else, doing something else. I'll get round to the documentation. We all know paperwork is done last. So we need to do the network assessment. I've called it audit. It should be assessment, really. Audit sounds like somebody with suits is coming in to see what you're up to. So I should say assessment. But this is really the first step in any deployment. What have you got? What's running? You really want to look at the routers. Anything else doesn't really matter. It's the routers that you're after. Maybe critical servers and services, but no, I'm just trying to focus on the routers first, because if you're not be able to move v6 packets across your network, well, your DNS server is not going to be able to do much either on v6. So let's just focus on the routers themselves. You analyze each point of presence, each location you have equipment, document the routers or other layer 3 devices that are going to be doing routing, how much memory, how much flash, disk drives, whatever they have in them. What are the software release versions? I mean, if you're clever, you probably have a software release strategy in your backbone. I'm only going to run 2 different versions of the vendor's favorite software because I don't want surprises in my network. Or if you just unpack it from the box, throw it in the rack, power it on, and if it moves packets, it's good, which seems to be what more people are doing. So if you've never documented anything and you're wondering where to start, I really like Rancid. Right? Rancid, really awesome network, whatever it was called, Cisco configuration diff or something like that. John Heasley put all that together. It's on the website. It's free. It's easy to set up. A lot of people use this. It runs every hour. It logs into your router. It will support, I don't know how many different vendors. It will pick up version information, running configuration, hardware configuration, software that's installed, and so forth. So you can just run through the logs. And the great thing about Rancid is every hour it does all this. And so any changes, it can notify you. And so you've got a running record of all the changes that ever were made in your network. And of course, if you do user access, authentication, authorization, you know exactly who's logged into your network and done things. So it's very, very useful bit of software if you aren't already keeping track of information. So this is if you're feeling lazy and you're not done anything, install Rancid, give it the SNMP community for your devices, and set it in motion. Saves you logging into a heap of devices around the backbone. Sanity check the existing configuration. Remove unused configuration. I mean, folks who have been to the workshops know that I jump up and down when I find configuration that's not longer used. Remove stuff that's not needed. Because if you forget something is there and you add something else in, there could be conflicts. And you know, we've done that often enough in labs, we see this often enough in real life. Take the opportunity to do a little bit of spring cleaning to tidy up the infrastructure. I mean, if that customer disconnected 5 years ago, why is the configuration still an interface? Because remember, what we're going to do when we dual stack the network is whatever we've got for v4, we're going to replicate in v6. So there's no point replicating things that are no longer needed. Check the software. Does the existing software have v6 support? If yes, deployment is easy. If no, dear Mr. Vendor, we need. Investigate what the impact is to actually upgrade. You may find that the software already exists. Sorry, the v6 support already exists in the software. Or your vendor may have a strategy of, wow, we had to spend millions of dollars adding v6 support into our operating system, so we want to recoup all that investment and we'll charge you extra for IPv6. The vendors who I'm referring to know exactly who they are. Right? They charge extra to get a v6 image. Quite often, is the image actually available? You may have a basic IP image, but can you get one that supports IPv6? Well, maybe you can, but then you don't have enough memory to store the image or enough memory to run the image. Or maybe it doesn't have the feature set that you have. So then you've got to think, well, what hardware do I need to replace? Do I have to swap the whole chassis out? Some organizations, if you swap chassis around, you've got to buy new stuff. It means procurement. It means RFPs, you know, open tenders and all the rest. So that starts being a bit of a big process. Right? So you need to start thinking about this. And this can take time. You know, we're not all lucky where we can just go out to our nearest friendly vendor and say, oh, you have a few things, and take them off the shelf and off we go. Budgets are important. Cost of operations, we need to buy the things, we need to deal with all the vendor lead times because most of them are building to order now, and then we've got to figure out when to install it. We've got to test the kit when it arrives, run it in the lab to make sure it actually looks and behaves the same with v6 turned on. Then we've actually got to put it in the backbone network itself. If the existing software supports IPv6, are the deployed software versions consistent across the infrastructure? You know, I've walked into so many network operators and found pretty much the operating system running is the one that came in the box at the time it was bought. Right? The 20 different versions of software running on 20 different routers. So let's try and make it consistent. Because generally when you phone your vendor and say, oh, I've got a bit of a problem with X, they'll say, yes, upgrade to this version before we'll talk to you. So you've got to go and then upgrade. And then they'll say, oh, but what's the software running on something else? Oh, you need to upgrade that too. So let's try and keep the software versions consistent. You know, maybe it's a core router has one version of software, and edge router has another version, something like that, whatever. It's just easier for troubleshooting, bug tolerance, and so forth. If the existing software doesn't support v6, then it's the cost of the upgrade to version which does. Feature compatibility, quite often you find that you go from one major release to another major release. The vendors decide, oh, I'm going to drop all these things and add all these other things in. Or maybe they decide, oh yeah, we'll give you IPv6, but no, you need to pay extra for OSPF version 3 because it doesn't fit or something like that. So you've got these weird things you've got to try and work around. Can the hardware be upgraded? We've talked about budgeting, purchasing, installation. If it can't be, then you've got to get new hardware. And then if it's hardware replacement, you've got to go through the whole process of getting a replacement product. And then the impact on the operating network, existing services, customers, and so on. So you need to run around that path quite a few times. It can take a matter of weeks. There's one operator I've helped who was not really that big at all. It took them over a year to get to a place where they could actually start turning on V6. So if you're sitting here thinking, yeah, I'll just wait until V4 starts being switched off, this hardware upgrade, dealing with the hardware in the network, is going to eat time. And when everybody else is running off to get router upgrades and so forth, yes, of course the vendors are going to be happy, but you know what happens to the lead times. They push out. And if lead times push out, and then your customers, etc., you know where that's all going. Anyway, once all that's been done, your network is now capable of running V6. We're not turning anything on yet. It's now capable. Let's optimize things. Is the V4 network the best it can be? Now, this is really pointing out that V4 networks have been deployed and operated for many years. If your business has been around for 15, 20 years, you're going to have a lot of things that, well, the configuration was put in there by somebody who left the company 5 years ago. We have no idea what it does, but we know if it's not there anymore, things break. Well, now's the time to actually figure out what this is doing and if there's another way of trying to do it. So optimization means, is the routing protocol the right one to use? If you're still using RIP, maybe you need to start modernizing. Do all routing protocols have the latest best practices implemented? Are your best practices what came out of the vendor manual, how to first configure? Or have you looked at some of the public presentations and so on about what a network operator's best practice configuration is for your infrastructure kit? What about the interior routing protocol? Do the metrics make sense? Do primary and backup paths work? So just take the chance to tidy up how the network is operating. There's probably a lot of things you can throw away that you no longer need. We do this in all workshops and so forth, always getting participants, right, we're not using this configuration anymore, let's get rid of it. We tidy it up, remove it, because we're moving on to something else. Because it'll come back and bite you in the future. It's inevitable. So motivation really means that if you're going to deploy V6 over your infrastructure, you're going to replicate what's there in V4. Right, so let's tidy up V4 to be as neat as we can, because then V6 deployment is whatever we did in V4, we do in V6. Right, so we want to avoid replicating V4 shortcuts or mistakes when we deploy IPv6. And introduce the improvements in the routing protocol best practices. These best practices change over the years. I was looking back at early slides like 2099 a few days ago, and what I was recommending there, because it was industry best practice, I would laugh at it now. Right? That's why you're quite often in the internet operations industry, you don't find many books about how this is all working. As soon as you write it, it gets out of date, because the best practices, it's a moving target all the time. So stay up to date with these. There are plenty available. You can search on places like Team Cymru and so forth, the various NSP mailing lists for a lot of the operational best practices. So take the chance to modernize the network. Only now do we get a V6 address space. Okay, so I haven't done getting V6 address space as the first part, because V6 address space, certainly for APNIC, is log into the website, click a couple of buttons, and click submit, and an email comes back with a /32. So it's not exactly difficult, so let's actually hold this off until we need it. So get from your regional registry. This is not promoting APNIC or anybody else's services, it's being blunt and realistic. Become a member, get your own allocation. This is very, very different from IPv4 days. Just become a member, get your own allocation. It's open to everybody running a network. Running a network does not necessarily mean you're a commercial ISP. If you're running a network, you may be a government infrastructure provider connecting government departments across a whole country. Well, you're still running a backbone. You may be an academic and research network connecting lots of universities and colleges. You're still running a backbone. You may be maybe an IT department for a multinational corporation, or even a national corporation with offices in many different states. You are running a backbone, right? So there are many of these entities that are running their own backbones who are network operators. It may be not commercial internet, but it's still providing internet services to different end users. So go get the V6 address. And generally, any organization getting a V6 address block will get a 32. That's the current policy available globally, /32. If you don't want to join the registry and get your own independent address space, you can get from your upstream ISP. And from your upstream ISP, as a corporate user, it's a 48. There's no kind of means testing as such as there was in v4. I'm not really talking about the detail of address planning and how addressing is working and all the rest, but basically, if you're going to your upstream provider, it's a 48. Okay, home users be slightly different and so forth, but as a standalone corporate, you get a 48. If you need to multi-home, certainly many of the registries have a multi-homing policy whereby you get a /48 from the registry itself, a provider-independent 48. Multi-homing with the service provider's 48, well, technically it's possible. In reality, you'll have a term and condition from your service provider saying, thou shalt not announce my address space to anybody else, or we'll cut you off. Or you might have to deal with filters. Again, most operators worldwide will filter v6 address space on a /48 boundary. So trying to do traffic engineering with, well, anybody's 48 is interesting, not really possible. But anyway, the policy exists. So the folks who need to do traffic engineering, by and large, are the network operators themselves. So refer you to my previous slide rather than trying to make a 48 work. Address planning. v6 address space actually is very large compared with IPv4, even that an operator gets. Right? An operator is getting a 32. So you think about it, /32, how many 48s in there? 16 bits? 2 to the power of 16 is 65,000. So there's 65,000 possible /48s in that address block. Some operators handing out 56s to the end users. Well, 56s, there are, 16 million 56s in a /32? So it's not just kind of something you can memorize as you could in v4. You don't have NAT in v6. So you can't just say, oh, just one address to each customer, simple, just number them sequentially, done, easy. No, you're starting to hand out 56 address blocks to your broadband customers. So you have to start thinking about how to actually build an address plan. But don't just walk in at random and just start picking numbers randomly out of your 32. Have a look at what industry current practices are. It's still a very developing area. There's still a lot of discussion. Everybody has their own pet address plan, and they will promote it as heavily as they can. Now, I'm not saying which is right or which is wrong, but many people have different ideas how to do addressing. It's completely different from v4. But certainly current practices include separation of infrastructure and customer addressing. With v4, we're living in a tiny little box. So the addressing was, oh, I've got some spare addresses. Okay, I'll use it for this router loopback. Oh, some more, oh, I'll use it for this customer. There's no real structure. So the security impacts in a v4 network were pretty serious because you had to try and document what was where to put periphery filters to protect your network core. v6 is easy. /48 for infrastructure, done, perimeter filter, no problems at all. But you need to think like that. You cannot think in a v4 world trying to do a v6 plan. So, as I was saying, the options for a v4 addressing plan are severely limited because of the scarcity of addresses. But for v6, there's no scarcity. The operator themselves does not have scarcity. Security policies are easier to implement. Addresses are easier to trace. Efficient plan is scalable. And what's really bizarre, I find V6 address plans are more memorable for network operators than the V4 address plans were. And I was one of these sad people who could remember all the IP addresses of my own ISP back in the UK. I could remember every single address, all the point-to-point links, loopbacks, and everything. That's pretty tragic. But V6, funnily enough, the V6 have helped deploy because you can design a scalable plan. It's even easier to memorize. You know, things like Nibble boundaries. A nibble is 4 bits, as you probably know. Each character in the V6 address is 4 bits. So we can start assigning meanings to the different characters in the V6 address. You've got plenty of scope of doing that. Nobody's going to come chasing you about how you've used the final /64 in V6 because that's up to you to use on the LAN yourself. So let's use this for a bit of flexibility. If you're going to hand out a 56 to your broadband customers, that's 256 subnets. You've got a bit of flexibility in there too. A 48 that goes out to your corporate customer. I mean, a corporate customer is getting 65,000 subnets. What are they going to do with all that? But that's the sort of thing that we're actually looking at. So let's try and use the Nibble boundaries, the nibbles themselves, to simplify the address plan. I mean, I don't have it in the slides here, but one of the things that I find really interesting, this is like deja vu. When I started doing all this, I mean, I was a network engineer, but I was also doing pre-sales support. And it's interesting the amount of end user customers we were visiting in 93 and 94 who were using network 10 for the address plan. And, you know, the first number was the 10, the second number was which building, the third number was which LAN. And then when we came and said, oh, internet, and oh, we'll give you a /24, they go, my addressing plan. But now with V6, they can actually rewind to doing this type of address plan, and nobody's going to look because they get a whole 48 to play within. It's very interesting. You know, there's nothing wrong with doing addressing as we did in V4. I mean, I always liken it to, you know, a student lives in very small digs when they go to university because the university halls are tiny little rooms where the student can basically sleep and study. And when you move out of university, we get our first job, we can then afford our own apartment to rent. And you live in your apartment, that's a 2-bedroom apartment, and you live in one corner of one room because you've always been used to doing that. And it takes you a few months to actually expand out into the rest of the room because you've been accustomed to living in a small box. So we need to start thinking about getting out of that little box that we had, which was V4, and living in the V6 space. So anyway, you know, this /61 that I've got here, there's nothing wrong with it. It looks perfectly fine. The address range goes from 0010 to 0017, perfectly good. But then the next subnet goes from 0018 to 001F. Nothing wrong with that either. But the thing is, the address blocks don't use the entire nibble range. So what we can do instead is use a /60 for this entity. And then this entity is identified by this number 1 there. They've got the whole range from 0 to F. So that entity can be identified by that number 1. So we can start attaching meanings to particular things. So I've seen network operators, okay, not at this point in the address space, but down here. So rather than numbering router loopbacks, like 1, 2, 3, 4, 5, 6, as you might do in V4, they start coding in which point of presence it is, which router it is, maybe which region it is, and it's all like the final 3 nibbles. It's all out of a /64, who cares? So nobody's going to look at any of that. But you can start building structure into the address plan. So we need to start thinking about that way of doing things, the old days. So go and find the really old folks, because they'll remember this from IPv4. I'm having a go at myself, because this was how we were always doing things in the past. But start using the nibbles as inspiration to design a scalable plan. So network operators will get a 32 from the registry. Address block for the router loopbacks. You can number all the routers in your backbone out of a single 64. I don't know anybody who's got 18 quadrillion routers, so we're not going to run out of a 64 for the loopback. Address them as a single 128. That mirrors the 32 we used in V4. Address block for infrastructure. I find a single 48 is fine for the entire global backbone. That's 65,000 subnets. Not many people have 65,000 subnets in their internal infrastructure. Some of the multinationals will split it up per region, though, because they have various reasons for doing that, with the way the network is working and how they peer and interconnect and so forth. But generally for any operator, start from a 48 for the whole infrastructure. What else? LANs, 64. Mind you, interesting things happening. For other reasons, some folks are using not 64 for the LAN. They're using /80s or 96s for other reasons. But generally, the spec says a LAN gets a 64. Okay, we pull out our broadband modem off the shelf. We power it up. What address does it present us with? 192.168.0.1/24. Why is it /24? There's nothing in v4 that says a LAN should be a 24. Oh, well, there was back in the 80s. We had classes. So this is not classes, but a LAN in v6 is a /64. So you can start thinking again of LANs are 64s, they're nothing else. Like we were in the 80s when LANs were class Cs and rarely anything else. Point-to-point links, protocol design expectation said /64 for point-to-point links, but number them as a 127. That's RFC 6164. Quite a few operators and more are doing that now. Number them as a 127. You still reserve the 64 for the link. I've renumbered enough backbones that were, well, let's say, misnumbered initially, and renumbering links from one size to something bigger is a big pain. Well, renumbering anything is a big pain in an ISP backbone. So reserve the whole 64 for the link still, but actually put the addressing on as a 127. We don't have a broadcast in v6, so there's no problem numbering as a 127. Folks who started off in the early days used a 126 because that mirrored the v4/30. I've seen people use 112s and 80s and 96s and 120s. But these days, generally, 127 seems to be it. I've seen some providers use link local, so they don't even use global addresses on the backbone point-to-point links. What else? I mean, these are some ideas. Your network operations center is part of your trusted infrastructure, so they could go in the trusted address block. Some people do that, some don't. Look what I've done. I said, take the last 60. Allows enough subnets. That's 16 subnets. Why a 60? Could be 61, 62. Yep, good old Nibbles. So I'm using a nibble out of the address block for the network operations center. Maybe critical services go there. I know some operators put things like the DNS resolvers and SMTP, Anycast machines, and so forth into the infrastructure block as well. Some do that, some don't. But these are just a couple of ideas. Links to customers. Customer links are not your backbone links, so let's keep them separate. So some network operators use unnumbered interfaces in v4. I know we did at UUNet. So could do the same for v6. Right? If you're ready to do something in v4, you can use unnumbered links in v6. It means the link has link local addresses, of course, and you can replicate the configuration you have in v4 for v6, works perfectly fine. Otherwise, use real addresses or global unicast addresses for the point-to-point links. And you can use a 48 for that or more. You can divide it up per pop, give a 48 per point of presence. It depends how big your network is. I mean, /48 in theory is for a site, for whatever definition of a site. So you could give a 48 per pop for numbering point-to-point links. That gives you 65,000 point-to-point links per point of presence. Or you can divide it up as I've done in this example. For 10 point of presence, divide into 16. Guess what? A nibble. So it gives a 52 per pop. Subnets in v6, you see, are all multiples of 4. You probably, if you're on the APNIC policy SIG mailing list, you see some discussion about changing allocation sizes and some folks saying, please make it Nibble boundary. Right? They're doing it for good reason. Why introduce extra complexity? It's not like we're a shortage of v6 address space. I mean, I shouldn't say it, but current global unicast is only 1/8 of the entire v6 address space. The current rate of allocation, we've got another 30 years at least before we run out of it. So I shouldn't say any of that, but you can start thinking some of these things. Look, if we really mess up 2000/3, well, we've still got 4000 and 6000 and 8000 and A1000 and C1000. So that's not an excuse for doing bad things, but again, as I was saying earlier, let's move out of the tiny little box we've been accustomed to and start thinking about constructing an address plan to live in the address space that we have. Anyway, back to this. Number the point-to-point links from you to your customer out of different address block from your infrastructure. I mean, this was possible in v4. v6 isn't introducing this as something new, but you've now got a big, big piece of paper to do your scribbling on, rather than the back of a postage stamp, right? You've got a big piece of paper, clean sheet, so let's try and construct something a bit sensible. And what else? Customers get a 48? Well, that's what the design expectation is. If they've got more than 65,000 subnets, A, congratulations, and B, give them another 48. It's very unlikely. I don't know any organization that's hit the 65,000 subnet mark. That's a lot. But in typical deployments today, even though the spec is the first bullet, the second one, I see more typically 48 for large end sites, 56 for small end sites, which tends to be your broadband, so home, office, small business. I mean, my ISP here in Australia gives me a 56. And yeah, that's fine. I've got 256 subnets from a house. I use 3. I'm unusual in that I use 3. Most people probably only use 1. You know, some of us here may have more than 3, but it's typical. You know, 256 is a lot, but that's the sort of thing that broadband providers are handing out. /60s, I see, it's not on the slides here, but some ISPs are handing out 60s to their broadband customers. That's 16 subnets. /64 if the end site will only ever be a LAN. And this is still a fairly active discussion area. Notice the numbers are multiples of 4. Funny that. Don't assume that a mobile end site needs only a 64. Some operators are distributing 60s to the smallest customers, as I was saying. I mean, this is fairly active discussion in the mobile as in mobile phone. How does your 3G or 4G dongle work with v6? Are you going to do DHCP v6? Are you going to do something else? I was going to ask Sunny, but he went out to the room at the very time I was, but he'll probably talk about it this afternoon. It's still a discussion area about how that's going to work, how tethering and all the rest will happen. I've given a couple examples here. DHCP pools of /48, you hand out /60 per customer, which gives you 4,096 customers per pool. Or it's a 56, a 48 is going to give you 256 customers. You can increase the pool size and so forth. I tend to prefer Nibble Boundaries rather than the 47 and 46 I've listed there, but you get the drift. Start thinking in those sort of scopes. And of course, don't announce all these individual bits and pieces out in your IGP. Or in v4, okay, we just had 1 IP address per customer, and they natted onto it. In v6, we're going to be handing out routed address space. Don't start carrying all this routed address space in ISIS or OSPF. It isn't designed to carry millions of prefixes. BGP is designed to carry millions of prefixes, but still announce the address blocks. If you didn't do aggregation in v4, you've got to learn to do aggregation in v6 because we've got a much bigger address space that the only winners if we don't aggregate will be the vendors selling you very expensive equipment. Business lease line, probably a 48 per customer. It's one-stop shop. You may have a small business, big business idea, you know, whatever. Again, nobody's really going to come chasing you saying, ooh, you shouldn't be doing that. Ooh, you haven't got utilization. The expectation is end site is end user gets a 48. Hosted services, I mean, again, it varies different hosting providers, you know, whether you have 164 per VLAN or put all the servers onto 164 or whatever. You know, there are many different ways of doing it depending on what the hosting providers do and the ease of setting it up on the hosting servers. You know, some hosting servers have a limit, operating systems have a limit to the number of v6 addresses you can put on an interface. But, you know, some can be up to 1 million or so, some are a few thousand, others crash when you go over 4 million. So it depends, but again, how the server handles hosting multiple v6 addresses on an interface. Some people do geographic delegations, so the actual customer delegations, they probably connect to upstream providers in one location, so they just start right beginning of the pool and we race through it. That's the sequential ones. Others will split the country into, or region into sub-regions, provinces or whatever. And then, well, in this example here, right, we'll take a 32, divide it into 36s, And then region 1 gets, oh look, a nibble, region 1, region 2, region 3. And so you can start identifying where you're handing out address space per customer according to the region they're in. And it gives 4,096 48s, i.e. customers per region. Makes it easier to remember the address space. And when you run out of address space, say you've got 3 regions, well, region 1 gets then 201 db84, blah, 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 and so on. While you do this, if you connect to the internet or other internet service providers in different regions and you want to do proper traffic engineering, you can do this in V6. V4, you just kind of shut your eyes and start spraying /24s all over the place, hoping that something works, which seems to be an unfortunately common strategy. It's not much engineering, it's just kind of, well, messing up the internet. Sequential delegations, yeah, here you carve off for your infrastructure and customer point-to-point links, then you just number your customers sequentially after that. Fine if you're sort of edge provider, you don't really have any traffic engineering needs to worry about. So routing considerations, I mean, this is more like routing best practice. Check what you're doing in V4. Make sure you don't carry all your customers and end user address space in OSPF or ISIS. They're not designed to do that. They're designed to get the routers to find each other. So use BGP. It's already carrying millions of prefixes for major providers. It won't object to you throwing a few thousand prefixes at it for your network. So traffic engineering. So again, think about traffic engineering plans for doing your addressing. Don't leave your addressing to the sales organization when they hand out address space to their end users. You as the network engineering folks and network operations department need to be in control of their address space, because if you're trying to do traffic engineering, load balancing, multi-homing, and so forth, having randomly assigned address space means that your traffic engineering load balancing will be randomly done. And that's not very useful. Yes, V6 can be renumbered like V4 can be renumbered, but trying to renumber customers works the same way in V4, as V6 and V4. You still, if you give customer address block, you have to give them notice that you're going to change their address space. You can't just say, oh, dear customer, can you just renumber? Because they'll have servers and services that have got fixed addresses that they can't just migrate at the drop of a hat. So you need to start thinking of the address planning to help your traffic engineering. Your backbone is not going to track traffic, right? Your router loopbacks, point-to-point links, they're not going to track traffic. They don't go downloading from YouTube and all the rest. Well, hopefully routers don't do that. Your customers will do. And so your customers are going to track traffic, so how you do address plan for the customers is actually very important. And you know, if you don't plan your addressing, you can end up with something like this. You take your address block, you divide it into 2 to do load balancing. So you announce the aggregate and say 2/33s to do load balancing on 2 external links. But if you number all your customers from this end of the link, from the left there, where's all your traffic going to go? Your traffic's all going to use the one half of the address space and nothing will use the other link. So a better way to do it is something like this. Balance the customer addressing out of the 2 halves of the address space. And this is an example. You'll have different strategies. You may have different business units, different type of customers you connect. I know we did. We numbered a heap of our business customers out of this piece, our residentials out of that piece, and then we could balance the external links based on how the address space was used. Of course, broadband customers were very easy to move around. Well, okay, in my day it was dial-up customers, but their address pool was much easier to move around. You couldn't move enterprises, because it was the usual 6 months notice for any change on the infrastructure. I'm spending a lot of time doing address planning because a lot of the training that I've been doing over the years, I find that folks can grab the concepts of the network. They realize, yep, the addresses look funny. They've got colons and hexadecimal things in them, but everything works the same. But when you suddenly put this massive address space in front of folks who are accustomed to dealing with this much, I don't know, it just seems to be a mental block. And it's something I've had difficulty with because I've come from the old V4 world where, in the classful days, where all that's happened is we've started big and got shrunk like this. whereas folks who've lived in this simply don't know how to exist in the big address space that V6 has. So I'm spending a lot more time, I find, in this presentation, as well as others, going through V6 address planning. So we can start thinking about these. Think a little bit harder about how to subdivide the address space to assist with your traffic engineering needs. What else? Yeah, so cluster assignments. Some people see reserve it per point of presence. I've never found that useful. Customers move. And so it just ends up messing your beautifully sculpted address plan. So I just go, well, okay, we use this chunk of addresses in this region. It's unlikely for a customer to move from this region to that region. Whereas they're probably going to move from point of presence to point of presence fairly frequently, as we found in Europe. So, but from region to region, less likely. Subnetting to try and cater for the multi-homing needs. Consider regional delegation, so the geographical thing I was talking about. Of course, we're using IBGP to carry all these customer prefixes. Backbone infrastructure out of the 48, as I said earlier, operational simplicity and security. V6 is not more secure than V4, but because of the ease of the address space handling in V6, it can be more secure because actually you spend more time. Well, you don't have to spend so much time figuring out the security as you had to do in V4. It's one simple perimeter filter to protect your infrastructure. So in that case, you probably could say that networks that have deployed V6 are more secure on the V6 side because folks have actually bothered rather than putting it into the too hard basket. Looking at the infrastructure, so it could be something like this, the first 48 for infrastructure, so the loopbacks take the first 64, maybe we've put the NOC in the final 60, and then the rest goes to customers. Or maybe we've included customer point-to-point links as well. Some other operators do it the other way around, because they say, well, everything is automated now for deploying addressing on the routers, so I don't need the short addresses. See, I use the short addresses for my infrastructure because I want to save my fingers and I want to see the letters on my laptop keyboard and all the rest. Whereas end users, well, it's their problem, they've got more typing to do. But, first come, first served. Where I've seen other operators saying, well, with automatic provisioning systems, we're not typing V6 addresses, so it doesn't really matter. But my natural instinct is to take the first address for myself because it's the shortest, the first 48. The other thing to remember is the registries will usually allocate the next block to be contiguous with the first one. Registries use a sparse allocation strategy, as you probably know. If you didn't know, APNIC has mentioned it often enough. So when you get a 32, the next ISP is not getting the next 32, right? It's usually out of a bigger block. It could be out of a /24 block or a /28 block, depending. If you don't believe me, do some whois lookups. Whois for your 32, look up the adjacent one. It'll be pretty likely to be unassigned. And you have to step along quite a way before you find the next assignment. So if you come back asking for another 32, you'll get the adjacent one. And that's part of the discussion in the policy SIG at the moment about, well, what should the next one be? Should it be a 28? Should we round you up to the next nibble? Or should it be a 31? Or should it be a 30 or 29? And of course, there are quite a few folks saying it should be a nibble. I like nibbles because it keeps the addressing simple and clean. Documentation. It's ironic, isn't it? So I've described a great way of using nibbles to have a nice, memorable address plan. And here we go. You think V6 addresses are so big, you never memorize any of them. And I'm finding I'm memorizing the address plans for all the providers I've helped so far, whereas in V4, haven't a hope. Not a hope at all. It's because we're able to use the size of the address to build a structure into the plan. But even if you don't want to do that, well, you memorize things, because memorizing is a bit of a single point of failure. You have lots of documentation tools. Here are some of them. There are probably more. I like NetDot because, well, Dean Pemberton, who was next door earlier, he did a demo of it. It's University of Oregon did it for their campus. It's a network documentation tool is what it did. And it's nice. It documents, it builds reverse DNS, forward DNS, a whole heap of things. It walks around your network, draws pretty pictures, and so on and so forth. It was good enough for them. That's a fairly sizable campus. Other folks can probably use it too. It's free, download it, have fun. Excuse me. I've seen people use Hacky. don't really know much about it. IP8T I've seen, FreeIPDB I've seen as well. V6 Gen is the V6 subnet calculator. So if you throw a 32 at it and want to know what all the 64s are, well, A, stand by for a lot of output, and B, I don't know. I don't find much utility in it, probably because I've been doing this far too long. SIPCalc, I've also seen folks use. It lets you calculate subnets for both V4 and V6. And it's like a command line tool that you can use if you wish. So there are some tools available. There are probably a lot others. Please don't come to me afterwards and say, oh, there's this. Well, maybe do, because it'd be nice to try and document if there are others that are useful as well. Some folks have said, oh, rack tables is really good. I've never used it. It's used for documenting equipment racks, but apparently you can record V6 addresses and so on in there also. But if there are others, there probably are. It's not a position as it was a few years ago where if you want to document V6 addresses, it was an Excel spreadsheet or a text file. So now we can actually have one or two online things that help. So where are we? We've spent, what, 45, 50 minutes talking, and we haven't even deployed V6 yet. And this kind of mirrors what's going to be happening in reality as well. You're going to have to do a fair bit of planning to get yourself ready before you start logging into routers and going onto interfaces and turning on V6. Right, so now, why did this not go next? Right, we're now going to put it onto the network. Where do you start? Actually, it doesn't matter. You could start at the core and work out, start at the edge and work in. Actually, what's important is don't miss any point-to-point links. It shouldn't really matter because we're logging into all the routers using V4. So you can start anywhere. Just don't miss things out. If you miss things out and then turn on routing protocols, funny things can happen. Starting at the core means addressing of point-to-point links is done from the core to the edge. That's what most folks are doing. You know, you start your core router, going to the edge router, the core router gets a low address, the edge one gets the next address. So you can then follow that strategy, but you don't have to. You know, you can start anywhere you want. You're not carrying traffic on V6, not running a routing protocol. As anybody who's done any of the hands-on workshops knows, you don't break V4 by adding V6 addresses, unless you do no IP address on interfaces, as some folks have done in the past. You shouldn't break V4 by deploying V6. It really doesn't matter where you start, just don't miss anything out. Number all infrastructure interfaces according to the established address plan. You don't have customers, don't worry about customers. You're doing your own infrastructure first. Be careful on LANs. If you turn a V6 on the LAN, if the server has V6 enabled, even though there's no V6 on the LAN, it will magically get a V6 address. And this may not be good. In fact, it may be bad, because you may not have any firewall or IP tables or whatever it is on the server itself. So even though you've secured it for V4, it may be happily talking to the world in V6. So let's be careful on LANs. I'll talk about that next anyway. Secure routers and layer 3 devices for V6 access. Turn on V6, remember it becomes V6 accessible. I've seen many networks who have bulletproof security in V4. They've turned on V6 support on the router, no filters on VTY, Telnet, SSH, SNMP, and suddenly they wonder why the whole world is logging into their routers and doing nasty things with them. Right? Once you turn on V6 on a device, make sure you've got identical security policies as for V4. LANs need special treatment. ISPs don't want to have router advertisements running around on their infrastructure LANs. People are not going to plug in devices and auto-configuration on internal infrastructure LANs. At least I shouldn't hope they will be doing that. So activating V6 in a LAN which isn't properly protected will have consequences. I say may, I'll be stronger, will have security consequences. Service goes auto-configure security, no firewalling, as I said before, compromise. So be very careful on LANs. Turn off all the capability for auto-configuration is usually the safest. Remember I mentioned about half an hour ago or 20 minutes ago that some ISPs don't use 64 on a LAN? Guess what? That's why. So they don't have any capability of auto-configuration. Interior routing protocols. Another topic. Make a decision about which IGP to use. Do you want to continue with OSPF or do you deploy ISIS? So this has been very interesting over the last 3 to 4 years. Notice I don't say anything about it, but I will speak it. I see a lot of people moving from OSPF to ISIS when they deploy v6. So ISIS is used in 8 of the 9 biggest global providers. Only one of them is still using OSPF. And there's quite a bit of, well, if they're using it, it must be okay for me. But also with OSPF, OSPF version 2 does not support IPv6. So it means you have to start running OSPF version 3. If you got the latest software from your favorite vendors, you might have OSPF version 3 with IPv4 address family support in it. But then you're running the latest, greatest, scariest software from your vendors. So some people are saying, yeah, forget it. We'll just use ISIS. Because after all, if the big guys are doing it, it'll be fine for us. That's all I'm going to say on the topic, because we could spend hours discussing it. I did last week. We can bring it up on Nanog mailing list. It pops up every, I don't know, 3-4 years, isn't it, Paul? Something like that. 3-4 days, maybe. But it's a frequent thing on Nanog. And, you know, we've had various folks. Dave Katz did a nice presentation at Nanog 2001, 2002, saying, well, there's no real difference. They're both link state protocols. Do the same thing. The vendors might be slightly different about each one, but they basically are the same. And then it pops up again. Somebody else did a presentation. I've done a presentation in various fora as well, saying, look, there's really no difference, but we'll leave it at that. Enable your chosen IPv6 IGP. Don't break v4. Right, so if you're deploying OSPF version 3, you replicate what you're doing in OSPF version 2. Check that adjacencies are all the same. If you're going to deploy ISIs to support v6, well, if you're using single topology, be very careful. If you're using multi-topology, who cares? Check adjacencies. You should have the same number of adjacencies. If you don't, something has gone wrong. Check the v6 routing table. It should look the same as the v4 routing table. Obviously, the numbers will be different, but you'll have the same number of entries. If you don't, you've missed something somewhere. Remember, it's just the IGP, just the routers in your backbone. I mean, those folks who came to the workshop last week know exactly what I'm talking about, because we sat down and we checked that everything actually matched, and they were most amazed that v4 didn't break. Of course, v4 won't break. It shouldn't break. It can't break. Fix any problems. In a dual stack network, the protocols must function the same way. And then you enable v6 BGP. So again, you're wandering around the network, turning on the v6 address family support in BGP. Again, it replicates v4. If you've got 4 neighbors in v4, you'll have 4 neighbors in v6. Right, so check all that. Obviously, you're going to have different number of prefixes, because your BGP in v4 is going to carry all your customers and internet routes that you've got and so forth, whereas v6 probably will have nothing apart from your aggregate. And then check that the v6 network's operation compares with the v4. Do a trace route from side to side, top to bottom. Does it follow the same path? If not, something is wrong. So do all that checking and testing. Right? It's your own internal infrastructure. Make sure you can access routers over v6 and all this type of thing. So right, we now have our backbone ready. We now want to talk to the world. Yes, getting v6 transit is way down the pile. Right? We're now at over an hour into the presentation. We're probably n days or weeks into our v6 deployment, and only now we're looking at v6 transit. Get your own infrastructure in place first, right, before we start. We're still not carrying traffic. All that we're doing with the v6 is, well, you can log into the routers over v6, and that's it. For traffic that's going to do downloading and uploading, it's still all over v4. So ISPs offering native v6 transit, they're still in the minority. But it's interesting, if you look at, say, the top 500, I think most of them have now got v6 enabled. How many are selling v6 to end users? Slightly less. But it seems to me it's the biggest providers globally have all done the v6 thing. It's as we get smaller and smaller, the smaller transit providers, you're finding more difficulty. I'm not going to pick on Australia, but getting v6 transit in here, not simple. Not as simple as it should be. Some parts of the world you expect will be least developed than this most developed country, and getting v6 is, yeah, sure, no problem, take your pick. But, at least here we are catching up. The next step is really to decide, are you going to give your transit business to those who actually provide dual stack? Or are you going to stay with the existing v4 provider and get some other type of v6 transit from somebody else? I've put tunnel in there. I really, really dislike tunnels for any type of v6 transit. The days of tunnels are long gone. We should be doing native everything and everywhere. Either option has risks or challenges. I mean, obviously the challenges with dual stack is, well, how well is the dual stack provider connected? I mean, there are two categories. There's still some providers, thankfully they're disappearing fast, who are trying to charge you extra for v6. It's like, why? They're packets. We can run the v6 packets through a v4 tunnel, then you won't charge us for them. So it's better to go with those who actually just sell you a pipe over which you send packets. It doesn't matter. I mean, they're just packets. They just have a different version number in the header. So much prefer the operators in category A rather than the B one. I think charging extra for native v6 is just nonsense. But some people are still trying to do it. Oh, well, we had big investment in our network to support v6. Yeah, but it's benefiting you in the longer term, so it's actually future-proofing your network. And of course, getting dual stack transit provider means you align your BGP policies. It's simpler to manage your traffic engineering and so on and so forth. And it saves money. You're charged for bits on the wire, not which color they are. Actually, I don't know any disadvantage of a dual stack transit provider. This is how it's meant to be. This is how it always was intended to be. And this is the easiest. You just set up another BGP session. If you've got separate v4 and v6 transit, you've got a transit provider who will only do v4 and they're not going to do anything else ever in the future. Well, my inclination is to, okay, terminate contract, as I did for my own home broadband. But you can buy transit from a v6 provider, okay. You may find a provider who can give you v6 transit for free. Unlikely, that's disappearing as more and more traffic appears running on v6, especially the likes of all the content providers I was saying earlier. So I don't really like this. I'm not aware of any advantage. It may be unavoidable. As long as the main transit provider can't provide v6. There's some countries I've been to where there's a monopoly national transit provider who's no plan to do v6 at all. So what do you do there? Usually the case is we build a tunnel to somewhere close and push the v6 traffic through that. Totally suboptimal, but if that's all you can do, that's all you can do. It could be a tool to leverage a v4 transit provider to deploy v6. I've known some of the big regional providers in Asia being forced to do v6 because their customers have threatened to cancel multi-million-dollar transit contracts. Right? We want v6. If you don't give us v6, terminate $10 million transit contract. Okay, we'll get round to doing it. And some of the major providers have actually done that. And then, of course, they've been able to offer v6 transit to others as well. And again, I've put the dollar numbers there, but it's going to be more expensive getting a separate v6 transit provider. You've got to pay for another connection, more transit costs and all the rest. And you've got all the separate policies. Managing and monitoring the network. Please don't throw away your v4 monitoring systems. We're not turning off v4. Some people seem to think we need completely separate monitoring systems for v6. No, we don't. Just access all the routers over v4 as we've done. We've got all these other things, NetFlow, MRTG. I should update this a little bit. There's others as well. Syslog can dump all things over v6. MRTG can dump over v6. NetFlow has v4 and v6 flow records. There are commercial systems, the other public domain systems that you can use that are all able to watch v6. Right? For example, NetFlow. This is not going to be exhaustive, but NetFlow, public domain analysis tool, NFSend, pretty nice. NFDump is the dump tool. It will listen for flow exports from your routers. It supports Cisco's NetFlow version 5, version 7, version 9 flow records. v6, of course, uses version 9. NFSend tools can be used to display and monitor v6 traffic. That's a very simple way of doing it. You can get commercial solutions around NetFlow and other flow information that can display your v4 and v6 traffic. That's all fine. MRTG is really old now, but I don't know, I've had this in here a while. But other tools, RRD and Observium and all the rest that can watch your network. Cacti can even handle v6 these days. But you can still monitor a lot of v6 activity using the existing tools. If you really want to, you can run MRTG over v6 transport, but why worry right now when you still have v4 infrastructure in your network? Okay, if you're v6 only, might be a bit more of an issue. Other interesting things. Dual stack network means that you can manage the network infrastructure over v4 or v6. And some folks are using this kind of pseudo out-of-band infrastructure. If you break v4, you can still log in over v6, and vice versa. That's what I tend to find. And certainly, if you're in a dual stack network, most stacks will prefer to connect over v6 first. So if you really break something in v4 in your backbone, you can still log in over v6, which is handy. Folks are recognizing it. The workshops I've been teaching are a lot easier now when we break things in v4 because I'll just log in over v6 and we can fix it. Whereas before, when I did the v4 only lab, it was like, okay, I need console access and working out how to do all that. v6 is preferred over v4 by design if quad A and A records exist for the device. Okay, modulo, the happy eyeballs and everything I talked about before. So final piece, customer connections. Yep, it's all the way down here we start looking at customers. The network is done, now let's connect the paying customers. This is a whole new ballgame. Take this presentation, present it to your customers. No, but seriously, this is going to be the big challenge. Let's get our own infrastructure in place first. Don't do the, I'll wait for my customers to ask, because A, they will never ask for it, and B, when you have to do it, you've got the last 70 minutes of presentation to work through first. It needs special care and attention, even updating of infrastructure and equipment. So mobile, cable ADSL, dial-up, yeah, we still have dial-up, leased lines, and wireless broadband. So mobile, well, 3G, 4G, Wi-Fi, WiMAX, any of these mobile type technologies. What about your handsets? Major corporations can be using that. We talked about the tethering and so forth earlier. Strategy depends on infrastructure, device capability, dual stack, v4 only with NAT4.6, v6 only with NAT6.4. We talked about DS-Lite, we talked about 464 XLAT, all that type of thing. Sonny will talk more about in the afternoon. At least he's here to see me say that you'll be talking about it more this afternoon. So that's on the mobile side. And there's a lot more to it than me just waving my hands in these two slides. So I'll leave that for the afternoon. But there's a lot of things to be thought about there. Again, I cursed my handset here because it doesn't support v6 over the radio. Hoping the new one that's going to be released tomorrow will. We'll see. v6 to broadband customers, so we talked about 6RD, but we can also use dual stack. My ISP here in Australia gives me dual stack. It looks and feels exactly the same way as v4. DHCP v6 PD hands out my v6 address, and we get it, and I live in a dual stack world, and I'm very happy. CPE are generally more expensive. Well, it's getting less so these days, as I was saying earlier. Some of the really cheap ones still don't have v6. Somehow v6 costs extra money to put the few extra lines of code and the little chip that's actually needed. I find that really hard to believe, but there's still some really cheap ones out there that can't do v6. But it's a lot better than we were 3 years ago. And if you have the infrastructure that can't handle the v6 ether type or whatever, or you don't have access to all your broadband infrastructure, then 6RD is the natural solution. There's nothing else really worth doing. So likes of Free in France, they were the pioneers of 6RD, and they use that. It's very simple to set up. When I do workshops, I demo 6RD in the lab. Very simple to do. Dial-up, gosh, v6 over dial-up. I had dial-up at home when I was in the UK in 1995 or 96, whenever we did v6 there. It just works, PPP v6, as we've seen before. I threw DHCP v6 PD in there because I was trying to be funny. I don't think that's a realistic thing, but anyway, it's possible. CPE, usually PC or laptop, because most OSs have supported v6 for many, many years, and dial-up service has been around for, well. Fixed link customers, very easy to get from you to their router. Beyond their router, through firewalls and all the rest, that's another matter, another story altogether. These are probably the easiest to roll out to make v6 available to the router at their premises. How they deploy v6 within their own network is a completely separate story. As I said earlier, take this presentation, repeat. Obviously, there are differences for enterprise networks. But it's basically take this, repeat, figure out what you need to do. What does need to be v6 visible as far as an enterprise goes? Maybe they only want to start with their public website, their public-facing servers and services, because the internal network is, well, v4 only, natted, and then we can think out a better strategy. How are we going to provide v6 addresses to end users on the LAN, and so forth? What's the strategy there? What about addressing? So we looked at this earlier. Mobile handset tends to be 64 at the moment. Home or small organization, some are getting 60s. Medium organization, more are getting 56s, like I do. Large organizations, so the big enterprises, 48s. There's no slicing and dicing as we had in v4. It's like 48, 56, 60, 64, done, end of discussion. I don't know anybody who's doing anything different. They probably are, but I don't know anybody who's doing anything different from these. The majority of end users, as I was saying, is a /56. What about customer end systems? Well, we have to start all over again. Is v6 available on their computers, other network-connected devices? How do we make great those which aren't? Are we still running Windows XP? Microsoft doesn't support it anymore, so what are we going to do? Yes, v6 is available on XP, but we don't really want to play there. What needs to be available on IPv6? What do you actually need to put that has to be available on v6? You may live with things like, well, does your printer need to be able to use v6? Your telephone system, all these ancillary devices in the core of the network, doesn't matter what protocol they're using. It's only really the things that need to talk to the world directly that probably need to be v6 capable in the start. Educate the customer operations staff, because you're now pretty expert at getting v6 running on your network, but your customers are going to be in the same state that you are in right now. It's like, ooh, v6, okay, I have to do something. Right? They're going to be the same thing. What's this amazing new thing you're bringing us? And why should we be doing it and all the rest? What about their CPE? I mean, if you've provided the router, it's pretty simple. You might just be able to plug, play, swap. What about the link between your edge device and their CPE? And of course, good old one, the security. IPv6 is not automatically secure, as many people have tried to provide misinformation about. If you do security in v4, you need to do your security in v6 as well. Right? v6 has some new features that you all need to be aware of, that your customers need to be aware of. And these new features are not insecure, but they need to be secured in the same way as all the existing features in v4 and v6 are. So that's us done. I mean, it's relatively straightforward to deploy v6, and I've sort of run through this in just almost an hour and 15 minutes. When you're deploying v6 for the first time, you need to have a strategy. You need to do planning. When you've got all that together, it's relatively simple to do. I mean, for sure, for all the people I've helped over the years, I walk in and we just do all this. We do it in this sequence and it just happens and people go, wow, amazing, it's all so simple. Why did I worry? But if you've never had to do something before, you know it yourself. Whenever you do something for the first time ever, there's always the fear and trepidation and the what-ifs and all the rest. But some of us in this industry have done this so often. It's like, yeah, okay, another one. Repeat, 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 repeat. It's actually very, very simple to do a network infrastructure. The challenge that you all have is for your customers, your end users, going through the same process that I'm going through right now with you, doing that same type of education to make them aware what they have to try and do. So I've highlighted the steps. These are the steps I've been using. There are probably other steps need to be included. There's probably a lot more detail. There's probably a different sequence. That's fine. What I'm trying to do really is point out, you need to have a strategy. And here's one that's worked well for me. If you've got one that works well for you, great. But I mean, the main thing is it's not as complicated to deploy v6 as it first seems. And that's it. Thank you all very much. If there are no Well, there can be questions. If there are questions, if there are no questions, we all get a slightly early lunch. Hopefully we can make it down to the restaurant before the rest of the conference. Otherwise, this afternoon, Sunny is carrying on the V6 tutorial, talking about 464 XLAT and various other things. So I'd recommend you to go to that if you're interested. Otherwise, thank you all, and we'll see you around in the conference.